Hey guys, my name is Yash Jain, and I've been working on a project that provides a 3D animated version of an NBA shot chart, as you could see on this website, along with a 3D heat map or intensity map that also has a range of efficiency from different points on the floor. So, as you can see, Steph Curry from 2023, he was pretty hot from this place on the court. This is the animation, the animated shot chart, so it's all of his shots from the 2023 season. And so let's dive into how I actually created this project. The hardest part was probably getting all of the visuals down for the basketball courts, the stanchion, the hoop, the backboard. I had to get those down. So we created this using Flask. The way Flask works is it allows you to define templates, which you could use for different web pages. As you could see, the home template, the template for the home page, which is just a slash in front of the URL, so it would be just represented by something like 127.0.0.1 colon 5000 slash. There's nothing after that. That would be the home page, after which we could provide arguments to our homepage as well. So arg1 and arg2, it would be something of the form. Right now we're just focused on the homepage, so let's see what we do in this case. If we're on the homepage, our arguments will only be of length 0. There will be no arguments. So this is if the length of the arguments is 2. Let's skip to the homepage. So now we're going into the render template on base.html. Let's open up base.html. Since the HTML file is quite long because of Matplotlib animations, we'll just look at the base viewer. So as you can see on this HTML page, this home page, we've created a form that allows you to put any NBA player from any NBA season. And the way this form works is it's a typable form. So if you want to type up a name, let's say LeBron, we will just type up his name, put it in the form, simple as that. And this is done through select to. As you can see, there's initially a blank op group, so there are no options inside of it. So there are no NBA players to select from. We create a script in order to populate this opt group. Let's just see where that is. So as you can see, we do fetch player file. Player file is an external link with it's basically a txt with all of the player names, and we fetch the player file, and upon getting the response from the player file, we add all of the player options to the opt group. So as you can see, it's opt_group.append new option, which has all of the players. We do the same thing for the season as well. We also have a submit button that is ID'd as submit. And what you want to do when you click on this button is you want to retrieve the information for the player and the season that are currently selected. And the way we do that is via this script right here. So when this submit button is clicked, we do this through the add event listener. What we do is we gather the player and the season that are currently selected, and we make the URL redirect to something of this form. So question NBA player equals player X and NBA season equals season Y. So for example, if I do it in this case, I would be redirected to the URL for Greg Anderson for the 1997 to 98 season. So as we can see, this takes a bit of time, but it will be redirected to something of this URL form. When we have a URL of the form NBA player equals this and NBA season equals this, obviously the length of the arguments will be 2. And after we go inside of this if statement, we create a figure and an axis that will be 3D, and from this axis we will define all of our shapes, such as the NBA courts, the hoop, the rim, etc., etc. Let's see how we create the actual drawing for the basketball court. So we do this in AxSpace. Define the floor, the 3-point line, the logo, the interior lines, the floor circle, the stanchion, and we've also defined the backboard and the rim, as well as the hoop. The rim and the hoop, they were interesting to draw because they were multiple concentric circles that were stacked on top of each other at different heights. That's how I created the effect of the hoop. So we'll go back to main.py. To actually find the shot chart of a player, we have to go into our shot chart function. We take two arguments, player name and season, and we match the player name to the player in our players list. Players list is basically a list of all of the players that have played in the NBA, and we get the career stats for that certain player. The reason we need the team ID is because we want the team that the player played on for that certain season. So we do this by doing career stats for that particular season, and after that we get a list, a shot chart list for that team, for that player on that season. This is our shot chart list that basically has a tracking of all the shots of a certain player, where they shot it from, whether they made or missed the shot. And we return this so that we could make the animation with this shot chart. After we create walks and lines, what we are doing is we're populating the walks. A walk is basically a path from a certain point on the floor, so for a certain shot to the rim. And we want to create a parabolic shot path from that point to the rim, which we do via the getParabola function. Let's go into the getParabola function. What we do is we create a t range such that the ball moves through t and it has a certain height. So our parabola, it's obviously moving through 3D space, but we want a 2D representation of it, which is what we do from t range, and we also set a z range, which is the height of the parabola. And then we return our parabolic coordinates. So for each of the walks, there will be a parabola that is assigned to each one of them, after which we create our animation. The way this animation function works is we've created an update lines function that obviously updates the animation on each frame. The number of steps is the number of frames that the animation will take, and the interval is the number of milliseconds between each frame. So after one frame plays, we have a delay of 30 milliseconds to the next frame. So let's take a look at the update lines function, which takes the arguments walks, lines, shots per rep, and the player shot chart. For this animation, we're essentially setting the line 3D data to a parabolic path, which we defined earlier, and we do this through line set data 3D, and we are also iterating through the shot chart makes. This is accessed through the make, and if you've made a shot, then you set the line color to green, else you set the line color to red. After we're done creating this animation, we save it as an HTML string, and we will feed the string as an argument into our HTML page base2.html. So this is a new template that we've created, and we'll feed the animation, the matplotlib animation, to that web page. Now we have to create the 3D heat map with a legend that marks the efficiency from each point on the court. And to do that, we will create another figure and we will define another axis. And what we do is we initialize these axes in axBase2. So let's look into the axBase2 function. Let's go here real quick. And so this is our axBase2 function. Obviously, what we want is we want the same courts, the same hoop, everything the same. It's just that the shot chart that will be appearing on top of it, that will be different. In order to do this, we first use the base canvas of the basketball court, which is defined in axBase. We then divide the basketball court, as you can see, into 20 by 20 grid, a 20 by 20 grid, which is given by x lin space and y lin space. As you can see, there are 20 points that we will create a mesh grid out of. And in this grid, what we want to do is we want to see the number of shots that a player has shot from that point on the grid, as well as keep a note of the percentage of shots made or missed from that point on the grid, or that point on the basketball floor. So what we do is we use ZKDE to track the number of shots that were attempted from that point in the basketball floor, and we use percentage to calculate the number of shots, the percentage of shots that were made. We do this through a simple loop in which we loop through all the shots in order to see from where they were made on the floor and also track the efficiency via the percentage matrix. ZKD and percentage, they are both 20 by 20 matrices. Now what we could do is we could create a surface plot which has the ZKDE as its height, and the color of the surface plot will be given by the percentage. So the color of the surface plot is given by the face colors right here. Now what we do is we do a simple convolution to smoothen out the ZKDEs, to make them less spiky and to make the plot more visually appealing. We simply convolve it with this simple matrix, 0.25, 0.25, 0.25, 0.25, and this is now going to be fed into the plot surface. So we're plotting the mesh grid of x's, the mesh grid of y's, and the ZKDE. We also initialize the face colors as the efficiency map, so we could see the percentage right here. This is going to be the face colors. And so this is what's done in the plot surface right here. After we are done plotting this figure, we save this figure via the matplotlib savefig. And just to make it cleaned up, we to make the margins tighter, we do bbox inches is tight. This is how we create the 3D shot chart. As you could see for Steph Curry, he took a lot of shots near the rim, which is why the height is so high at this point. He also took a lot of shots from the three-point line. He's the greatest shooter of all time. So we could see that the height at the three-point line is great. It's very high from many areas. You could see the general distribution of where he takes his shots from, as well as the places he's hot from. So this is our NBA project, and I think it's pretty useful to have an overview of some crazy shots that some players made. For example, if you play out the Steph Curry season, you could see he attempted some wild shots from very far, and it's cool to see them illustrated. He didn't make these shots, but cool to see some players still attempting those shots, and via this animated shot chart, I hope you could see this. The GitHub, as always, is in the description. So thank you for watching, and I will see you soon.